Okay, for this question, I've got a question here where the length of potatoes harvested on one particular farm can be modelled by a random variable where the lengths measured are between 5 centimetres and 22 centimetres. So already we've got a little bit of information there. And the next thing is the most likely length of a potato is 11 centimetres. Ooh, okay, so straight away we can see that uh, we're likely here to be dealing with a triangular distribution. And the reason for that is that we've been given 5 centimeters and 22 centimeters. So that means we've got a minimum and a maximum. And then it says the most likely length. So that means mode, okay, is 11 centimeters. So we're going to be using the appropriate model would be a triangular distribution. And it says for the probability that two randomly selected potatoes, so that's another important piece of information we'll come back to, are both longer than 14 centimeters. So basically what we're wanting to find out here, what is the probability that X is greater than or equal to 14 centimeters? And because we want two of them, we want to square it. Okay, so for the triangular distribution, we have to remember we've got this diagram here, and where A is and I'll just write this down for you, A is equal to the minimum value, which in our case is 5 centimeters, where B is equal to the maximum value, and in this example that's 22 centimeters, where C is the most common or modal value. In this case, that is 11 centimeters. And then if I superimpose on this particular graph here, we're wanting to find, so for example, if that's 5, that's 11, and that's 22, we are looking for 14 and above, which just as an estimate, we're looking for this probability here. Remembering that the total probability beneath this triangle is equal to 1. So we're trying to find that there. And the first step we're going to do is we're trying to find that value X there. And by doing that, well, we know that's 14, sorry. We need to find this height here because the area of a triangle gives us the probability. Okay, probability. And we need to know, and the formula, of course, is half base height is equal to the area of a triangle. And we've got the base. We can see that the base is this distance along here. So the base is equal to 8 centimeters because that's 22 minus 14. We just need to find the height. We need height. And there is a formula for that, which I'll go on the next slide, but that's the information we've got. So we can see here that just carrying on this problem here, we've got our triangle here, and we've got the formula for each part of the triangle here. So I just want to highlight which each part is, of course. So this first part here, X is less than A, well, that's over here. So, of course, it's outside the triangle, so the probability is 0. Likewise, going past B, this one here, that's outside the triangle again, and again the probability is 0. The two parts of the equation we're interested in is this first part here, where A is between A and C. So that's that part of the triangle there, that half. So between the minimum to the mode, we would use this formula that I've highlighted in blue. For the other half of the triangle, so this area here, we use this formula because that's in between the B and the C, or the C and the B. And we're going to be using that side because we know that our value is between those two parts. So yeah, we know we're looking for something that is greater than 14. We're basically looking for what is the probability of X being greater than or equal to 14. So in order to do that, we have to work out the height using these values. And it's simply a case of substituting values in. So we'll use this formula here. So the function of x is equal to 2. And then we substitute the values in. We know that b, the maximum, is 22 centimetres, minus our value of x, which is here, that's 14, close the brackets, and that's over 22 minus 5, and then 22 minus 11, because that relates to b minus a and b minus c. So therefore the function of x, or that point of x, if we multiply all that out, is equal to 16 over 187. So that there, if we were to draw a line there, that's what we're looking for, is that area in there that I've just coloured in yellow. Okay, what that's telling us is that the height of the triangle at that point x, where x equals 14, is 16 over 187. And we know from looking, we wrote it out on the previous screen, but from here, we know that the area of a triangle is equal to half times base times height. We know that the base is 8, because that's between 14 and 22, and the height is 16 over 187. And if we multiply that out, we get 64 over 187, which also equals, if you put it as a decimal, 0.342. But we haven't quite finished, because if you'll remember, it was wanting to know what the probability of selecting 2 of these such potatoes. So basically, we are looking for the probability of x is greater than 14 all squared, which therefore equals 0.342 all squared, which equals 0.117. And that is the answer.